afternoon, everybody. Thank you all for coming out to the talk. Can everybody in the back hear me well? All right. AV people, is the audio levels fine for the people in the future on the internet who will be watching this, hopefully? Yes, good. All right. So it is 2 o'clock. I'm going to go ahead and get started because I don't want to run late and then cause people to miss other talks later on. My name is Kojo Idrissa, and I'm giving a talk on software engineering, what I call a junior developer's guide to software engineering. And so the basic premise of this talk is what are the things that you need to know as you are trying to make a career transition. So as you can see from the slide here, I'm realizing now I've made the cardinal sin of having something too close to the bottom of my slide. So now I'm a QA specialist working for a startup in Houston. But before, I've been a software developer for about 2.5 years. Before that, I was an accountant and a university instructor in a couple of different countries. And so I'm one of the people who has come from a non-traditional background. I didn't get a CS degree and then start working as a developer. And as part of that process, I've met different people who have gone through that similar journey or are trying to make that transition. And so that's what this talk is for, sort of to help that sort of people in that situation. It can also be useful for people who are trying to hire new developers, and I'll get into that a little bit more later. So again, so here's the issue. You've got these people who are changing careers, but they're looking for these junior developer positions, or some sort of internship, a developer position, a way to get started as a software developer. The problem is there's not really a good definition of what junior developer is. Junior developer often generally means someone who knows less than me. In much the same way that senior developer often means someone who knows about the same stuff I know. And so that's not super helpful. And so the issue is, okay, well, when am I ready? You know, when am I ready? How do I know enough, in this case Python, to become a software developer or to get a job? So more programming. Just, you know, there's so much emphasis on trying to learn more Python, and that's what career changers tend to do. But in the same way that you don't become like an author or a journalist by just memorizing all the words in the dictionary, you can't become a software engineer just by learning more Python. The reality is there's more to being a software engineer than just knowing more about the language that you're choosing to use. So how much Python do I need to know to get a job isn't really the optimal question. And so we'll get into sort of what are some better questions to ask instead of just trying to learn more Python or more Django or what have you. So there's a secondary issue, which is how do you mentor new developers? And so if you are in a situation where you're hiring developers or you are in a position where you need to mentor a newer developer, what do you need to teach them? What do they need to know? What do they need to focus on? That can literally be its own separate talk. And I've got to talk on that, and maybe I'll present it someday. We'll see. So when I talk about software engineering, again, the title of the talk being a guide to software engineering, there's a distinction that I make between programming and software engineering. And so here we have these distinctions that I make. So programming, something that's often done by individuals. Often, if you're just writing code, then you've got code that's primarily being run by the author of the code itself. And the code might not need to be super robust, because if you're the one who wrote it and you're the one who's primarily running it, if something goes wrong, you can just adjust it. On the other hand, I'm contrasting that with software engineering. And we're looking at this from the perspective of people who are trying to make a career change. And so if you are looking to be hired as someone who makes software that is going to be used by other people or even make open source contributions, it's a different approach. That software is going to be built in teams, not by one individual. The software is almost always going to be used by people other than the people who wrote it. And as a result, that software needs to be more robust. It needs to be more stable. You need to have more assurances that the software is going to behave as you intended. And so a brief interjection here. If we look back at this slide, it might look like I'm sort of making a distinction between like real programmers and not real programmers. This isn't the case. If you've written code that runs and does what you want it to do, you're a programmer. Congratulations. Please see someone and get your official decoder ring. And we look forward to seeing you at the next meeting. And so, but there is a difference in styles of creating software. So if you are writing software for yourself, whether to solve some sort of problem you have, whether you're a researcher. I used to be an accountant. I've written code that solves some of my problems. You're a programmer. So don't worry about that. But you might try to look at one of these two different styles. There's also this idea, this sort of lone genius myth of like, oh, well, if I were like a real programmer, I'd be able to just sit down and I'd be able to just like write all sorts of awesome code that worked. That's not a real thing. Please don't think that. Probably the biggest example of a successful open source software project is Linux, because Linus Torvalds just wrote that all by himself one night at home. No, that's not true. It's something that's been built by a community of people from Linux to Python to Django. It's software that's been built by groups of people working together. There wasn't just one really smart person who like Django'd really hard and then made Django. That's just, you know. And I put this here just to say, don't try to compare yourself to that false standard, because it's just not a true thing. So when we're talking about, let me go back, when we're talking about software engineering, though, again, the reality is you're going to be working in teams of people, and your software is going to be run by people that you don't know and don't have access to you directly. And so you need it to be robust and to be fairly solid. So what are some of the functional details I'm going to get into? What are the things I'm actually going to talk about? I've got these 5 topics that I'm going to talk about. And the basic idea here is that if you are looking to sort of career transition and to become a software engineer, these are sort of the fundamentals that you need to be familiar with. But one of the keys I'm going to focus on is not just the what, but more so the why. And the question, the why and the timing. So why are these things important? And then when should you start using these? What I've run into in dealing with different people is that people often think that they need to be a more advanced programmer before they start doing some of these things. And the truth is, no. You can start literally after you've written your first or second line of code, you can start doing some of this stuff. And so, and that's sort of the idea of this talk, is when and where you can start doing these things, and how developing these practices will make you a better software engineer, but also make you a better candidate either for software engineering jobs that you're looking for, or to be able to contribute to open source projects that might be important to you. So let's get started. And I'll be using a sort of a tell and show approach as opposed to show and tell. So I'm going to go through and discuss some of these things, and then towards the end I'll have sort of a demonstration of some of these things. The idea being, hopefully that will be useful, so that if you haven't seen some of these things, depending on what experiences you've had with Python and software development, maybe you've seen and done some of these things, maybe you've heard about them, but you haven't actually seen them enacted. So I thought it would be useful, might be of some value to demonstrate some of these things. So the first thing we're talking about here is version control. Right now, the most popular version control software is Git, and there are other options that exist, but Git being sort of the most popular one. So why? You don't just use version control because people say you should use version control. There are actual reasons for that, and the primary reasons are, it helps you protect yourself from mistakes that you might make, and it also makes it easier for you to try new things. And so with version control, you write a line of code, it works, you commit that code so that okay, this is somewhere that's safe, and then you go on and make a change to the code, and then you make another commit, and so you have this trail so that if somewhere you break things, you can take a step back or 2 steps back or however many steps back you need to. That's sort of the fundamental premise of version control. This is in contrast to the saving a copy of a file with a different name. So this is mycode.py_1, then mycode.py_2, or mycode.py_final, or then final, or no, for real, this time it's really final. So those are just sort of basic fundamentals of why you use version control as opposed to just renaming your files. And so it protects you from making mistakes. It gives you a little more freedom to try new things, because you can, and I'll talk about this a little bit more, you can branch off and try something new without worrying about it breaking what you currently have. But then this bottom point, it helps you to learn to work with a team. If you're building software, or you're trying to prepare yourself to be able to build software in teams, these are the types of tools that teams use, and we'll get into that a little bit more later. And so that's the why. When do you start using version control? Well, do you need to start? Do you need to wait until you're writing complex object-oriented software, or until you've written 1,000 lines of code? No, I've got this sort of arbitrary breakpoint of 10 lines of code or more, or when you've got code that works and you're scared to break it by making a change. And that 10 lines of code thing is really more of an arbitrary threshold of, you know what, I don't mind like retyping 8 or 9 lines of code. But if I have to retype like more than 10 lines of code, that's a hassle. So I don't, you know, that's too much. And so I need to do something here. But also when you've got code that works, then you're scared you're going to break it. So you've written a certain amount of code, it does what you want it to do, and you're like, okay, now I need to add this other thing, or I need to change this aspect of it so that it works better. But you're like, I don't want to break it though. And so whenever you start to get one of those feelings, that's exactly the time to start using version control. You can use it before then, but as soon as you start to get either one of those twinges of, oh God, I'd hate to have to retype all this, or oh, I don't want to break it, boom. This is when version control is your friend. And so how do you use it and why? You can start using Git on its own by yourself. People will often conflate Git and GitHub, and while the two are often used together, they're not the same thing. Git is the version control software that lets you keep track of changes that you make to your software that you are writing. GitHub is a place where you can share that code that you've written with other people and collaborate with other people. However, if you're not familiar with using Git and you haven't developed certain practices around using Git, those collaborations become more difficult and they become more problematic. And so even if you've only written a few lines of code, literally 2 or 3 lines of code, really 1 line of code, you can start to use Git and start to build those habits of making what are called atomic commits, so that the changes that you make from one step to the next are small enough that you can isolate problems. Because if you write 100 lines of code and then you commit it, and then you write another 100 lines of code and you commit it, and you write another 100 lines of code and commit it, and then it breaks, well, like you've got 100 lines of code to go through to figure out where the problem was. But if you're making smaller commits and these atomic commits, and the size doesn't have to be based in lines of code, it can be in functionality. So if you change one feature, and then if you change like 3 features and then commit, and something breaks, you don't know where the problem is. But if you change one feature and then commit, then the second feature and commit, you can isolate the issues. And so, but you don't really start to develop a feeling for that particular rhythm until you've actually been using Git more. And so using it on your own is important. And you can do that, again, as soon as you start programming on your own. And then this basic feature branch and merge workflow. This is one of the key parts of working in software teams and collaborating, making use of Git. And so when I talked before about being afraid that you're going to break something, this is where that feature branch and merge comes in. And in the demo that I'll do a little bit later, we'll have a graphical representation of what that means. But I'll do a very lo-fi version over here. Like you're writing code, and your code's progressing, and then you decide, okay, I want to make a change, but I don't want to break this. So you branch off, and then you make some changes up here, and if it works, you can then merge it back in here later. But if it breaks, the breakage stays up here. The code down here still works just fine. It's my very high-tech approach. So, but we'll see an example of that a little bit later that's a little clearer. But again, these are things that you can do on your own. And so if you are writing some software and then you're worried about breaking it, just make a branch. Once you get that branch working, merge it back into the main code. And this is one of the killer features of Git. It makes this branch and merge workflow very easy. And it also makes it much easier to collaborate with coworkers. Actually, it makes it easier to collaborate with coworkers, but it also makes it easier to get other people to review your code. So among other things, I am one of the organizers for DjangoCon. DjangoCon US, come and see us in San Diego in October. But literally this morning, like 3 hours ago, I was reviewing a pull request from one of the other organizers about an update to the DjangoCon US site that will probably get pushed out next week. So this is just a thing people do, but having this branch and merge workflow just makes it that much easier because you can make changes or a teammate can make changes and it's not going to break anything. And then once you've determined, okay, that change works, you can merge it back into the rest of the software. So that's sort of the how. As far as a reference goes, if you're like, well, okay, Kojo, that sounds fantastic, but how do I learn to use the Git? I don't know how to Git. What do I do? This is one of the best references I found. One, because it's authoritative, but then 2, it is also free. And so it's called the Pro Git book. It's available online there, that link. But if you just Google Pro Git book, you'll be taken to the website. And the reality is the first 3 chapters of this book will give you about 80% of what you need to know about Git. You need to know how to git init, to get your Git repository started so that it will start tracking your software. Git add to add a new file to that tracking repository. Git commit to save those changes. And then there's a branch and a merge. And that's most of what you will do with Git. There are lots of other advanced features. You can go down a rabbit hole. And that's the nature of this talk is I'll touch on a lot of things. There's a huge amount of detail that you can go into on any of these topics. But the reality is you can get started almost as soon as you start coding to start making use of Git. So this book is available. It's free. First 3 chapters are available. Each chapter is broken into a small section that's easily digestible. So you can get started with this immediately. So the next thing here is documentation. So you've written some code. You've got it. You're using version control to keep track of the code, keep track of your changes. So you've got 2 different types of documentation. In-code documentation, which is actually about the code, which is in the code that you're running, versus documentation about the code, i.e., how do I run this? Like how do I make Git work, or how do I do that sort of thing? Here I'm talking about starting with code in your document. I'm sorry, with documentation in your code. So not documentation about how to run the code, but actually how the code is written itself. So another little interjection here. How many of you have heard of the idea of self-documenting code, by show of hands? Right, okay, so by applause for the people on the internet who can't see you. But how many of you have heard this idea of self-documenting code? Yeah? So good portion of the audience, the people at home can't, or on the internet can't see you all raising your hands. Self-documenting code is this idea that, well, you don't need documentation in your code. If you've written good code, it's self-documenting. That's kind of true, but not really. So here's the reality. Naming things is hard. And so if you're having trouble like trying to figure out how to name things, that's a hard thing, and so don't feel bad about that. But the sort of the tiny kernel of truth in self-documenting code is that code can seem self-documenting if the variable names and the function names are all excellent and they tell you what those things are doing and how they're doing it. And so if you can write code like that, fantastic, but it's not the easiest thing to do, and it's getting better at that is something that happens over time. And so until you reach that point in your development, put comments in your code. And the comments, you can put them in to explain what you're doing or explain why you did a certain thing or why you made a design decision. So this trying to move towards a self-documenting code approach is theoretically possible, but it's harder than people make it out to be. There's just sort of this blank statement of, oh, well, good code is self-documenting. It doesn't need documents. That's kind of a thing, but not really. So watch out for that. So how is documentation helpful? It does all these things for you. If you're starting to document your code, and starting to document the things that you're doing in your code, it helps you think about what you're going to do before you actually start writing code, which is valuable. It also helps your future self. So in some of the demos that I'll show you a little bit later, there are comments that I wrote like 3 years ago. And they help me run this code and do things with this code. You can also avoid what's called technical debt, the idea of having to go back and change your code later, but then not knowing like what is this? What did I do? And I assure you, no matter how smart you are or how smart you think you are, you will write some code at a point in time. And then at a later point in time, you'll forget why you wrote that code or what was going on. So just help yourself in the future. Put comments there so that later on you come back and say, oh, this is what I did. I'm super smart. Look at me. So that's important. But then again, when we go back to looking at software engineering and how software engineering is done in teams, it makes it much easier for your teammates to help you, because instead of you having to sit down and have a conversation to explain things to them, they can just look at the comments that are in your code. So this is important. So when do you start documenting your code? There are 2 specific situations that stand out in my mind. One is when you're writing code that's using some sort of a technique that is new to you. Not like a brand new, like a new feature in Python 3.7, but something that is new to you. So if list comprehensions have been around for a while, but if you're writing your first bit of code using a list comprehension, add some comments there to explain what you're doing or why, so that when you go back to that code, it'll make sense to you. Use comments to help remind yourself of the design choices that you made. Okay, well, I used a tuple here as opposed to a list for this reason. And so you'll understand why you're doing that. And then also, when you start to write functions, especially if those functions call other functions. So if you're writing functions, this is one of the first places your code becomes less obvious. If you're not writing functions in your code, and a function is just, you're just grouping together a chunk of code. But if you just got lines of code that run in sequence, it's much easier to understand what's happening there because the first line runs and the second line runs and the third line runs, and you can just read through line by line. If you have a function, then you're typing some word, or some set of words and then passing something off to that function, and it's doing something, but you don't know. And so putting documentation in your functions makes it much easier to debug them and to have an understanding of what's going on with those functions. Because again, if you've got one function calling another function that then calls two other functions or passes something to another function, you've got a lot of indirection and it becomes confusing very easily. So how do you do this? Again, talking about functions, the minimum that you want to do once you start writing functions is to include docstrings in your functions. And what do you want to include in that docstring? You want to include some basic description of what the function does, and then some basic information about what that function takes in, including a data type, and what that function returns, including its data type. So does this function take in a string and return a list? Does this function take in a list in a dictionary and return a tuple? Those sorts of things can help you debug functions because, again, you've got a lot of indirection there. So one problem you might have is, oh, you know what, this function is expecting to get a string. I passed it a list. That's not going to work. Yes, in certain aspects, and we'll see a little bit of that later. So the question was, do docstrings function the same way in Java? The Python has a built-in help function, and so if you type in help and then whatever the construct is you want help about, the help that it gives you back is the docstring. And then there are other things that can be done with that. But this is sort of like, once you start writing functions, this is what I think is the minimum documentation you need, because this is what helps you to make sense of what's going on. But it also, again, if you're working in engineering teams, it helps your teammates understand what's going on. No. Well, that's a different thing. So documentation, so here, this is sort of like the minimum where you want to start. And then once you've gotten a little further with that, what are your sort of your next steps? You can try to start to learn a markup language like ReStructured Text or Markdown, and this is where you start to get more into creating external documentation that you want to be able to share with other people. You could also learn about the Python documentation standards because, again, we're here at PyOhio. I'm hoping that people are using Python. That's why you're here. And so looking at the actual documentation standards for the Python project is a good place to go, a good model to use as far as how you should be documenting your own code. There are questions. Okay. No. Yeah. Well, yeah, I don't really have an opinion on type hinting. It's just, it's useful to know what data types your code is using, what data types they're expecting. So the next thing we look at is testing and test-driven development. So why do you want tests? Literally, there's so many reasons. And so I'm going to jump into sort of a big thing here and try to go through it as succinctly as I can. But testing leads to a lot of potential benefits that you can't get unless you start with testing. So here's the big picture on testing. If you have tests, you can then have automated tests. If you have automated tests, you can have CI or continuous integration. Continuous integration can lead to unfortunately, there are two things called CD. Continuous delivery and then continuous deployment. And so automated tests are tests that can be run without a person having to push a button each time to run those tests. And so that sort of thing tends to happen on what's called a CI or a continuous integration server. And so if you have tests, you can write tests that will be automated tests so that each time you make a change to your code, your continuous integration server will run your tests. And so as your code base gets larger, you add more tests to it, but all those tests are being run all the time. So the tests are there to help you make sure that your code isn't broken. This continuous integration process keeps that going. It keeps checking the status of your code for you. And then after you've gotten continuous integration going, you can try to move on to continuous delivery, which is a situation where each time you add new code and your tests are passing, you know that, okay, this code is ready to be deployed to a customer. Maybe you don't deploy it right then, but it's ready to be deployed. Now, the next step from that is continuous deployment, where each time you add new code, the tests run on your continuous integration server, and then the code just gets pushed out live because you know that the code is functioning the way you expect because all your tests have passed. So this continuous deployment sounds almost like magic. Okay, it's like I've written some code, I hit commit, I push it up to wherever it goes, and then boom, my customers get brand new functional software. And that's the thing that can happen, but it can't happen unless you first have tests. And so that's sort of the big why of tests. So now that's definitely a much more advanced thing that comes much further down the line, but you don't get any of that unless you start with tests. So why should you write tests as a new software developer, a new software engineer? One, it protects you from future changes breaking things, but it also gives you some assurance that past fixes will work. So there are lots of different types of tests, and again, just testing itself can be a whole different thing. I think there are 2 talks later this afternoon about testing. I'm going to focus on 2 types of tests here, unit tests and regression tests. Unit tests are tests, and again, it's a subjective term. They are tests that test a specific unit of code. So you've got some small bit of code. Is it doing what I think it should be doing? Sometimes it's the function, sometimes it's 2 functions together. And so a unit test specifically tests that small chunk of code. So that's probably a good place to start. But then there are also regression tests. A regression test is a situation where you've written a test, you've written code, you found some sort of bug in your code. You're like, okay, this is the problem. Let me fix this. So I fixed this, but now I want to make sure this issue doesn't come up again. I want to make sure I don't regress or go back to that broken state. So you write a regression test that makes sure that that fix that you made works. And the reason I sort of focus on those 2 tests, those 2 types of tests, unit and regression, is because I think conceptually those are the easiest 2 types of tests for newer developers to figure out. If you've written code that prints someone's name, then it's not that hard to write a test that says, okay, does this name show up? Does this value that I passed, does it show up? Or if you've written some code and it breaks in a certain way, it's not that hard to figure out how to write a test that makes sure that break doesn't happen again. And so those are good places to start. But then those can become automated tests that lead to the whole CI, CD thing. Because that's where you want to go. But this is where you start. And so there's also this idea of test-driven development that I'll sort of touch on. You can start to think about test-driven development very early in your programming career. It might not be a thing to focus on. Test-driven development, pure TDD as it's called, is where you write your tests before you write your code. Now, as a new developer, that can be confusing, that can seem complex. The advantage of TDD is that it forces you to think about, okay, what am I trying to write here? What am I trying to do? And it forces you to think about that and to try to write a test for it before you actually write code. It's similar to how documentation works, documenting your code, speccing out what you want to do. But the difference here is the test is actual code that will run. And if it passes, then you have some idea what's going on. Now, should everyone start trying to do TDD at the very beginning of their programming career? Maybe not, but it's a good thing to be aware of. And so it's good to start thinking about writing tests. So when do you start writing tests? As soon as you can. I was having a conversation with the gentleman in the front a little earlier before the talk. Writing tests is both an art and a science. And so the more experience you have with writing tests, the easier it gets and the better you get at it. Because what you need to test and how you need to test it varies dramatically with the software that you're dealing with. And so there's not just like one hard, fast rule for testing. And so the sooner you start writing tests, the better. And you know what? Just like with learning to code, you're going to write your first code is going to look really terrible to you like 6 months later. Your first tests are going to be the same way. But you don't ever get better at testing until you start writing tests. And they can be very simple. But again, experience with testing helps quite a bit. And so how do you do this testing? So Python has doc tests and the unit test module built in. And so that's a good place to start because those are built into the language. If you have Python, then you can run doc tests and you can use the unit test module to run tests. So that's a good place to start. There's also a module called PyTest, which is a third-party module. And it has become sort of the preferred test runner And the reason I have that as sort of as a separate thing is it does add a little bit of complexity because you have to install a separate thing. It's not that difficult to do, but if you're concerned about that, just start with doc test and unit test because those are already there. If you have Python, you already have access to those. So a few other things I want to talk about: dependency management and deployment. And these are two separate but related ideas. Dependency management is making sure that you have the different parts that you need to run your software. So if you are, say, I gave a talk here last year on using Python with spreadsheets. I'll just use myself as an example because I know me better than anyone. So I gave a talk on using Python with spreadsheets. To do that, there's a library that you use called OpenPyXL. So if I'm trying to write software that helps people work with spreadsheets and I'm trying to give that to someone else, part of that dependency management process is making sure that OpenPyXL is part of the package that gets given to someone. There's also the issue of making sure you have the right version. And so certain different versions of software, as you know, software gets upgraded. As a new version comes out, it might have new features, new functionality. So that's part of dependency management. And then deployment is the issue of getting your software to run someplace that's not your laptop. Because, again, when we're looking at programming versus software engineering, as a programmer, you might run software that just runs just on your laptop. But if you are trying to do software engineering, you're writing software that's going to be used by other people, you have to be able to deploy the software in some way. You have to be able to get it to other people so they can make use of it. And so that's where these things come in. So here we have virtual envs, containers, and virtual machines. Virtual environments solve the dependency management issue. They help you create a literal virtual environment where you have the specific versions of the different dependency pieces that you need, and you can keep track of those. Containers, if you've heard of Docker, containers are another way to solve the dependency management issue, but they also help with deployment because you can then take a container and there's infrastructure somewhere, so you can plug that in to that other place, and all your dependencies are inside that container. It makes it easy to deploy it. It makes it easy to put it where other people can run the software. Virtual machines do a similar thing to containers. The technology is, virtual machines are considered sort of a little bigger and heavier than containers. But again, the why here is what I'm focusing on. Why do you need to know about dependency management? Because if you don't make sure that the pieces that your software needs are available, your software won't run. And if you're not familiar with how to get your software from your laptop to someplace where other people can use it, then you haven't done a great job of software engineering. Other people can't use your software. And then what are some other things to focus on? Being familiar with your development environment. Are you using a command line interface or are you using a GUI? A graphical user interface, pointing and clicking. If you're using a CLI, command line interface, how comfortable are you navigating that interface? What things do you need to learn? And those details will vary depending on where you're working, who you're working with, what you're doing. But that's another set of skills that you can work on improving. So again, each of these is in contrast to just trying to learn more Python. Instead of just trying to learn more Python, learning more, you're learning about testing, learning about documentation, learning about how to navigate your command line interface. There's also this idea of a terminal multiplexer, this third bullet point, and I'll give a brief demo about that because that's a little easier shown than described. But here, Screen, Tmux, and Byobu are examples of terminal multiplexers. Those are things that help you avoid having a jillion tabs open in your terminal. And again, we'll see an example of that later. And then at the bottom, a shell language. So if you are doing software development, especially in a Unix or Linux-based environment, there are times you're going to want to work with your operating system. So you're going to want to, say, copy a file from here to there, or instead of running 2 or 3 commands by hand, you know, if you keep doing that, if you keep having to type the same 2 or 3 commands over and over again, you can write a shell script that will put those commands into one script and then just type one thing and run those. And so for that, you'd want to know the shell language of your operating system. And again, when we talk about your development environment, are you developing in Windows? Are you developing on a Mac? Are you developing in a Unix or a Linux-based environment? Knowing the shell language for your environment lets you do those things that helps you automate those processes, make things more efficient. All right, so lots of talking about stuff. So now it's demo time. And this is where things could all just fall apart. So whenever there's a demonstration, things, as we call it in Houston, the treacherous live demo, that's a thing that happens. Let me make sure I'm hydrated before I try to demonstrate things. All right, so here are some things I'm going to give a brief demonstration of. We talked about Git and branching and merging. With Git, there's another command called git log, and that shows you the history of the commits that have been made. I'm going to show you something there from a repository for the PyVideo project that shows what that branching and merging structure looks like. It just makes it a little more obvious. For documentation and testing, I'm going to show you some things from a project that I made, some software that I wrote, where I've done a little bit of documentation, a little bit of testing. And then I'm going to show you some examples from my PyOhio talk from last year, where we look at dependency management and dealing with your development environment. So let's try this. Let's see. All right, so now it gets okay. There we go. All right. Here we are. Okay. So that work. Okay, and let me try. That's not okay. That and that. There we are. And I'm going to bump this up. So this is always the tricky part about these things, is figuring out how visible things are. So people in the back, is this visible? All right. All right. Okay, I'm sorry. Yeah. Oh, yeah. Oh, yeah, exactly. Yeah, and that's why and for those of you at home who are sort of concerned about it, let's see if I do this. So if things sort of end up on the bottom, then, and so now you can't see the stuff here. If you do, on most Linux or Unix-based systems, if you hold down Control L, then that clears your screen, and then boom, everything's back at the top. So I hit Control L a lot because I prefer to just have a clear screen because that makes things simpler for me. All right, so that'll sound terrible in the audio. Sorry. So we're going to start here with this example of the git log from PyVideo. So if I type in, let me just do it here. And so this is PyVideo, a website that has videos from a number of different Python conferences. If you haven't gone to PyVideo, go to pyvideo.org. It's awesome. It's great for learning. You'll find all sorts of amazing stuff there. And so that's the directory. If I do git log, it will show me, and it'll start to show me in order like what the last commits were. So for people not familiar with Git, that yellow long number is the identifier for that specific commit, and then who's the author, what's the date, and then add use links is the commit message. So that describes what was in the commit. And so we've got a list of those, and that's not terrible, but it could be better. So what I'm going to do is I'm going to cheat and use this really long command. So you saw me type git log before. So here we have git log. That -- graph is saying, okay, I want the log output to be in the form of a graph. -- pretty means I want it to be pretty, which is important in software development. And then it equals format, and then the rest of that are formatting codes to give colors to the different branches and things of that nature. If you go to Google and type, what is it? It's like git log one line pretty. You'll find a page that will give you this long script. So don't worry about trying to memorize all this. But that's basically what's happening here. I'm doing git log, but I want it to be in the form of a graph, and I want it to be pretty, and I want there to be some color coding. And the reason I'm showing you this is because this is a little more helpful to see. It's abbreviation. It's abbreviating the commit IDs. So instead of that long yellow number we saw before, you're seeing those 6-digit red numbers with the stars next to them. Okay. So what we have here now is that I think that should be visible. Let me move that over a little bit, just to make sure that it. There we go. So if we look from your perspective, the left-hand side, you see all these stars. Each star is a commit, and then you'll notice you've got some spots. So if you look at maybe midway down the screen where it says fix random link script, you'll notice that star is off to the side. That's where you've had a branch. And I think the next one is so here we've got a slightly better view. So we can see here on the far left we have, that's what's called sort of like the master branch. And then all the things, those lines and stars to the right are places where you have branched out. And I'm just going to flip over here. So here, people have branched out from the main branch and created these feature branches and then merged them back in later. And so when I talked before about this branch and merge thing that you can do with Git, this is what that actually looks like. So if there are, say, 4 of us working on a thing together, we can all start from a common point, and each of us can make our own separate branch and work on things. And then as we have those things working, we can then merge them back in. And so here we have things branching off. We have things branching off and then merging back in later. So here, the thing is branched off and it's merged back in here. And you'll see the messages here: merge pull request, merge pull request, merge pull request. And so this pull request is the idea that someone has done something and they want it to be merged back in later on. That's something that I approved someone's pull request this morning. And so this is sort of what you see with Git, and this is the power of that branching and merging. This is what makes it easier for you to work in a software engineering team with other people. But it also works for you by yourself. It lets you go off, make a branch. Maybe it completely breaks. And if it does, you can just delete it. But you've still got your original working code. So but let me sort of hold questions until afterwards, because I want to make sure I cover all the things that I'm trying to cover here. So this is what the Git log looks like. Then we're going to take a look at, there we go. So this is a project of mine. Wrong cursor, here we go. Move this over. The other trick with demos is just the movement of files. So this is a project of mine. I was playing with the Twilio API. This is an application where if you send a text message of a certain format to a number, it's for Dungeons and Dragons, for die rolling. And so if you send a message in a certain format, it will roll dice for you and then text you back the results, because I'm a nerd and that's what I do. So, exactly. And so when we talk about documentation, where's my, can't find my cursor. There we go. So when we talk about documentation, so you can see the code here isn't terribly complex. This is a dice class. This is the actual die that you roll. This is the die that you actually roll here. I've got comments here. So this is sort of my core function, and the function is telling me, take a string describing a die roll, return the roll result. So that's what's going on here. Here in this module, this is my input valid function, and this is what makes sure that the input, the text that gets sent, is in the valid format. It needs to be in a certain format. And I'm telling you here, you know, it's taking in a string and it's returning a string. And then if there's a regex match, it will say the match is found, but if not, there's no match. What you see here are doc tests, and this is something that's built in with Python. Python will let you, this looks like typing things into the Python interpreter, and so you can actually run these as tests using the doc test module. See here, I have more standard sort of unit tests. So this is a test to test the die roll. Is it rolling properly? If I say roll a 6-sided die, am I getting back a number that's in that range or not? And I left my cursor again. Okay. Here I've got some other tests where I've taken those doc tests and turned them into other tests to make sure that if something gets sent in the wrong format, it's not going through. So here, for instance, you shouldn't be able to send 0d8. So in Dungeons and Dragons terms, if you wanted to roll one die that has 8 sides, you'd say 1d8. If you wanted to roll 2 dice that had 10 sides, you'd say 2d10. So you shouldn't be able to roll 0d8 because there's no 0 die. Also, you shouldn't be able to roll 10d0 because there's no 0-sided die. So each of these is a test. You can see assert is none because the result you get of passing this to my input valid function should be none. So these are the tests. And let's see, let me jump here to, so make that bigger. So this is running the test. So this is using the built-in Python unit test module. Is that, you all see that in the back? Yes? So Python-m, meaning I'm running it as a module, unit test. I'm telling it to discover. I want it to find my test The dash V is verbose because I want the output to be as verbose as possible. I want to see all the detail from the output. And then tests is the name of the directory where my tests are living. And so there's that result. And I'm running out of time, so let me do one more thing. Let's see. So that's unit test. You can also do the same thing with PyTest. And so this is me running a simple PyTest. And PyTest makes it a little prettier, a little more colorful. So I am out of time, and I don't want to hold anybody else up. So let me bring back this. If you have any other, here we go. If you have any other questions, there are a couple of talks you might want to go to later today if you want to know more about. There are 2 talks later today about testing. One tomorrow about containers, and there was a hands-on guide to teaching talk that happened this morning that you can watch the video for. I might be working on a tutorial about this. If you've got questions or comments for me, I'm most easily reached on Twitter as Transition. Thank you very much for your time, and I'm here to at the conference if you have any questions.